Path Solutions has over 2 decades of experience building network monitoring systems designed to give you total network visibility. TotalView's automation means it can be fully deployed and configured in minutes, monitoring every device, interface, and server in your entire infrastructure. And it goes deep, collecting performance, configuration, 19 different error counters, PoE, and QoS statistics on every single interface. Now, all of this information is automatically analyzed to produce plain English answers. Problems get solved faster because more information and intelligence is brought to bear. This is what total network visibility is all about. Knowing more about your network than with any other solution. TotalView is easy to acquire as everything is included in the core offering. NetFlow, diagramming, path mapping, server monitoring, network automation, IPAM, cloud service monitoring, and more. Putting your trust in a monitoring system can require a leap of faith. From inception, TotalView has a more secure architecture and build process that helps to protect their customers. Contact Path Solutions today, where you can learn more about their competitive upgrade program, Total Network Visibility, rapidly deployed. Find out more at www.pathsolutions.com. Tony, my friend.
Hey, buddy, I'm doing well.
I don't know about you, but every time I listen to that, I'm sitting here grooving, and I'm like, okay, I got to stop by the time the camera comes on. It's just got that nice little groove.
Yeah, it is. It is. It's a total groove. I tell you that nearly every time. It's awesome.
So, man, so what's new?
Man, actually, I was on PTO today because I'm having a little transition in childcare. So I was doing PTO today, but so I've just been like, dude, I've been looking forward to this all day. I haven't had work to distract me. So I've done like a little bit of like personal stuff and getting ready for stream. And we're going to have Greer Greer to talk TCP. And
yeah,
dude, I'm totally excited.
Yeah,
we're also going to have a championship trivia night.
Yeah. So Donald Sharp is going to, defend his current. Well, I mean, so we don't have a champion as of yet. We haven't done a monthly champion yet. This is the first one.
That's right.
But Donald came out strong, winning the first couple trivias, and so Donald is going to be defending his reign as the trivia champion, standing trivia champion. I don't even know how to say it, but he's going to be going after that first monthly prize. So I see him hanging out in the background here on the feeds. You can't see him or hear him right now, but he's there. He's ready. He's in the
green room.
He's in the green room. Yeah, he's in the green room.
And something else that's so funny about Donald in trivia is that he's been on trivia, I think 2 or 3 times, maybe just 2.
No, I think he played last week, but he didn't make it to the final.
Okay, so
I think he dove on purpose. Like, that's just my take. I think he dove on purpose because we were giving him a hard time. You created that graphic. Like, are you smarter
where's
than
that graphic?
Donald?
Do you have that graphic?
I do. I can bring it up.
Put it up.
Yeah. So this is the graphic, right?
So I made that.
Yeah.
Are you smarter than a Donald? That's what we're here to find out. And you don't know, I made that graphic and I put an Ethernet cable through the middle of it, and I made it like Cisco console blue.
I see that. We'll bring it back out so people can see what we're talking about. Yeah, I see that.
Yeah, in the middle. So I could have made that any color I wanted. The default was, I don't know, black or something. So I went ahead and, tried to match it up with the Cisco console cable as best I could.
Now, see, if you really wanted to seem like you were really on your game, the ASRs ship with a yellow console cable.
With the yellow cable, that's right.
Right. And so if you did a yellow, it would just be like that one step further.
And the yellow cable, if I remember, isn't flat. It's a rounded cable.
That's right. That's right.
Mm-hmm.
The yellow cables were sought after just because it was something different other than the stupid flat blue cable that everybody had like 30 of in their desk or in their bag or whatever. I think I'm down to my last one. That's how you know when you're not doing a lot with like actual hands-on like deployment is when the Cisco console cables have all kind of dissipated, and I'm down to my very last one.
I was gonna say it's when you actually take the Cisco console cable out of your travel bag because you're like, I'm probably not going to need this. Like mine is sitting shelved. It's over there on the shelf. It's not even in the bag anymore. I won't need it.
Yeah, well, I mean, and I'm doing so much with like software defined networks and stuff now. Like I can't remember the last time I was consoled in. I'm sorry. Kevin distracted me. Kevin says he's here for the UDP deep dive.
Of course he is.
Sorry, Kevin. I think you are at the wrong show, buddy. So anyway, yeah, I don't have a console cable with me. I have one in my desk drawer, but I don't carry it with me. Like, I don't know. I manage PowerPoint now. So and when I am touching something, it's SDN.
So something I found early on in my networking career, when I first got like my little CCNA stack, that I bought from the guy on Craigslist, I got my console cable. I had to buy a USB to serial adapter. And so obviously, I'm new in my career. I don't know what I'm buying. So I buy like the first piece of junk I find on Amazon. Looks good enough. What do I know? It just looks as good as the rest. And what I found was that one has a prolific chipset.
Yep.
And I found early on that prolific chipsets, and I don't know if it's a specific version, but are prone to crashing when they receive too much data from a console. So even though they're 9600 baud, right, or at least the device is by default 9600 baud, still the prolific doesn't keep up. So actually, I went and found that the one that I have now is actually a really old one. It's using an FTD chipset. And the FTD chipset has like a little memory chip in it. It doesn't matter how much data the console is feeding into it, it constantly feeds your console at an even rate. So like you never end up like blue screening. Because what would happen is I'd blue screen the computer. If you do like a show tech, you'd get like a couple of lines going and then the computer would blue screen because it's just too much data. And FTD chipset fixed that. And now they make those ones that you don't need adapters for. They're just USB on one end and RJ45 on the other, and they're built-in FTD chipsets. So Those are like super convenient.
The prolific, I never had it crash because of too much data being pushed, but I did have the prolific driver on Mac was particularly finicky for many years. And anytime you pulled your USB to serial adapter out of a Mac, it would crash. It would crash the machine. Like it would just cause a blue screen essentially. Of course, it's different on a Mac. It's not a blue screen, but it would reboot. And so like it got to the point where it's like I would plug in as little as possible for the serial. I'd try to find any other means possible. They did end up fixing the driver, but it was a long time afterwards. And so, I'm very familiar with the chipset drivers because you had to go find specific ones. They weren't built in like on Windows where it just worked. Like you had to, had to go and make it happen. There's all kinds of syntax and resets and all kinds of stuff going on in the chat. What the heck happened?
We're trying to denial of service Kevin out of the chat.
Is that what it is?
By giving him a sin flood. So he can't chat.
Well, what's funny is there's a bunch of sins and sin acts, but only one that is an act to all of them. And it's 3 acts in a row, which I think would cause anything to just puke if you got 3 acts sequentially. Anyway. Apparently everyone came ready for a TCP conversation. Guys, it's coming. That's coming.
Great.
Yeah, it's great.
Yeah, in fact, that's what we're doing. We're just testing the flags right now. That's all.
Is that what it is?
So far, we only got 3. Let's see if we can get the rest of the flags in there.
Oh, there you go. There you go. So first off, guys, that TCP conversation with Chris is the primary part of the show today. And I'm excited. Like we said, we're excited about that. It's one we've been looking forward to. But we want it to be as interactive as possible, right? So he's going to be demoing and talking and whatever. But if you want to participate and you want to influence the conversation, if you want to ask questions, if you're not there now, the YouTube chat is probably the best place to go. You can go to networkcollective.stream if you're watching us elsewhere. That's the best place to get to the YouTube chat and all of that. Or you can go find us on YouTube if you're watching on Twitch or on Twitter or on Facebook or any of the other places. We watch that chat, but the large majority of it happens in YouTube. And so if you want to participate in the fun, make it on over to YouTube and get in on the chat. Hey, and there's Chris. Chris is in the chat too. Okay, this is going to be fun. Chris, if you put in the additional flags, it doesn't count. Nice.
Yeah, I don't know what Chris is talking about. Chris Cummings is talking about there's a huge thing with fake FTDI chips. We might have to take that to a Slack conversation. I'm not sure what that is. You need to catch me up, Chris Cummings, on drop me a link to an article.
Yeah, they were cheap, stolen, manufactured by China, if I remember correctly. And they went in everything, and they weren't the official ones, but there were ones that mimicked them. And it was a pretty a prolific problem. There it is. You still keep the bell around, even though you've got the sound effects.
Okay. So let me back this up. The reason I have the bell, okay, you guys might find this humorous. You might find this sort of demeaning. The reason I have this bell is at my company, we do interns. We don't hire. We provide internships to people fresh out of college. And we got a couple of really, really good interns one year. And one of the guys just could take a joke really well. And now he works for us. Now he's full-time and one of our best engineers. I absolutely love him. His desk was sitting facing an open door in my office. So it was as if he was like my countermaid. And so I bought him this bell to go on his desk. And I bought him the take a ticket thing, the pull a ticket and put it on his desk. And so when people would come to the door, every single person would like look at him and look down. And they'd be like, so do I just leave a message if I need to talk to Tony or something or what? Because it looked like his desk was blocking the door and that he was like my secretary. And so I bought him the bell and the please pull a ticket thing. And when we sort of shuffled offices around and I moved my desk to home, I reclaimed the bell.
Nice. So we have our first awful TCP joke. I just want to highlight it.
Hit it.
Yeah. So it's Laz. Just no surprise there at all.
Let's talk about TCP.
Oh, you don't have to sing it, Tony.
And me.
We want people to stay.
Let's talk about all the Synnec and the resets. You can think. Mm-hmm.
Okay, we're gonna stop now. You needed some music with you there. The acapella thing wasn't working.
I hit the trombone. It didn't play.
What?
I hit it twice. It didn't play.
Would you like me to play it for you?
Yes, please. Thank you.
So I see Nash has joined us tonight. Nash, I don't know if you've joined us for a stream before, at least not in the chat. Maybe you did, and it's been a while, but it's good to see you. Nash went and got a job, and now she's super busy.
Yeah.
Don't see Nash around the chat as much. Chris, okay, so apparently I was wrong. Chris Cummings says Tony singing is why he comes to the stream. Nice. And then Nash also supports it, says he has to sing it. So my apologies. I definitely thought that people would prefer you not sing that song.
This is also like a counterculture networking American Idol audition. People didn't know it, but that's actually what we've reduced ourselves down to. My 4-year-old dying at Tony's sound effects. I can't even play this. I have the whole soundboard in front of me. When I click the button, they don't work. I don't know.
Nah, it's just because I've killed your access to them. I'm like, no, just not going to happen. All right. So first up today is trivia. So we've been doing this recurring, ongoing trivia, and now it's time to see who the winner of the month is. And we kind of covered this. Donald's going to come up, but winning last week was Thomas. Thomas, are you still there? Thomas's video is off, so I hope he's still there. I see some audio from him, so I think he is. There he is. Yeah. Okay. So this is the culmination of this month. This is the winners from this month. Typically, this might be 3 people, but considering that Donald just wins. That Donald just wins, that he's taking the 2 spots for this week. He doesn't get to answer two different answers for each question, though. That really wouldn't be fair. So I don't know if we're ready here, but I think it's time for some trivia. What do you think?
Yeah, definitely. Absolutely. Yeah. So for anyone who hasn't seen this segment of our show, is normally on Wednesdays throughout the month, we do trivia night. We normally do a qualifying round where anyone in the chat can come in and play.
That's right.
And we host it on Kahoot. It's a lot of fun. There's some nerdy networking trivia, and then there's just some regular nerdy trivia. And what we do is we take the top 2 people from the qualifying round and have them go head to head. on the same night. So we invite them back, we put them on live, and we have them go head to head. And Donald has won head to head twice. Tom has won head to head once. And this week, or this month, I think having 4 Wednesdays in it. Here we are. We said we were going to have a championship round of all of our weekly winners at the end of the month. So here we are at the end of the month, and our 2 winners are Tom and Donald. Let's bring them up.
All right. So let's make sure we got their audio going.
I want to go on record and say I did not intentionally lose last week.
Okay. On record that he didn't lose on purpose. So
Exactly.
so no taking a dive.
No.
And Cabaginator. How do you even say that?
You got it. Cabaginator.
Cabaginator.
It's a cabaginator.
Cabaginator? Cabaginator? I'm not sure. What happened to the nose? What happened to the nose?
I just want to say also, and maybe I didn't say this in the beginning of the show, but all of the times that Donald has played trivia with us, he has never used any semblance of the name Donald.
No.
It is more fun.
It is. Yes, Preston, it is the end of the month.
Okay,
all right, guys,
hold on.
are you guys...
There's something we have to address first, though, because this has come up, and it's an important question that needs to be answered. Because you're the one. So if this is Network Idol, who gets to be Simon?
Well, one of you needs to put on a white T-shirt, then, don't you?
Sure.
Yeah,
we'll figure out the attire. That's fine. So there were a couple suggestions in here, and I like them both. One is Greg Farrow. I think Greg Farrow would make an excellent Simon. And
he's Simon. That's it. No, he's Simon.
But no. The other one is Jeff Houston. You can't just dismiss Jeff Houston like that. Jeff Houston would also make an excellent Simon.
Wow.
Are there any others out there, or is it just straight up one of those two?
I would go Greg, just because I know Greg more so than Jeff. I would go Greg.
Okay. What do you think, Donald?
Wow.
Definitely Greg.
So it's going to be unanimous. so Greg is the Simon of network American Idol. It could be American Idol because
does he know that he's been bestowed the title?
No, but we probably should tell him.
I think I'm brewing a meme right now with his face on it. So we'll get something out on Twitter soon.
He'll find out when it's publicly announced and everyone. Oh, there was a suggestion for Yvonne Pepignac.
Oh, okay.
But see, no. Greg. Yeah, I'm still going with Greg. All right, guys. So you guys are both in. We have covered up the pin so other people can't just randomly join. I've kind of been waiting for somebody to figure out a way to hack that little bar I put over the top of it and randomly join a game like the first time we had this. When we did the trial run and we're like, hey, we're going to try it with one other person. And the next thing you know, there's like 8 people in. It's like, oh yeah, idiot. Don't show the pin on stream. And maybe you won't have everybody jumping in. So let's get this started. So first up though, we're going to need some music, I think, right?
Oh yeah. Yeah, definitely. You had some good tunes last time.
Yeah. So let's there we go.
Yeah, it's good trivia music. All right, guys. So you ready for your head-to-head? It's going to be the 2 of you. I don't know how many questions we have. February Tournament of Champions. Here we go.
13 questions. Oh, look at that. Like it's nothing. These guys are pros.
All right, but Tom was quicker on the draw.
Super close. All right. Taking a bit of a deviation from networking here. Okay. Look at this.
So, quick question. How do I move my picture so I can read the screen?
Oh, listen, I've never been a guest on this show. You're asking me? I have no idea.
Oh, you know what? Wait a second. Donald,
I got it.
In the little hover over box. Yeah.
Yeah,
All right, here we go.
It's kind of hard to read the question.
All right, Thomas keeping the lead. And you guys are fast. There's a reason why you guys have won the previous trivias. That was quick.
And that's the Fibonacci sequence.
It is. I had to find a picture of the Fibonacci sequence that did not have the numbers in it, which is actually really hard to find, actually. All right. A little bit Birdie just hanging out there. Woo! Hey, all right. Finally,
someone got one wrong.
Look at Thomas pulling ahead. Very nice.
I have no clue. I know it's not 88.
I put that in there just for you, Donald. That was a giveaway as to what it isn't. All right.
Wow, this is pretty good. And you know what? I like that a lot of the questions that I've submitted are being pulled for this trivia. I feel honored that
it's almost all you
know,
on this one. So
it's sweet.
If this one's bad, it's Tony's fault.
And also we got some questions from the Network Collective community that we desperately needed, and I've seen at least one used so far. So thank you very much for everyone who submitted questions today. Appreciate it.
All right, good deal.
What?
You asked this one already.
No, we didn't.
Why'd you get it wrong?
No,
I didn't get it wrong.
Okay, all right.
Oh, look at that. Took the lead.
Oh.
We did not ask this. We asked an IP header, Donald. It was different.
That's right. Right. Yeah. So that's why I like those two questions is, in the layer 2 header, it's flipped from the IP layer. Isn't that cool?
So Chris Cummings, I post this up here. Just, I can't not groove. It's just not,
Oh, and this one. This is where
this
it
is
has
the
the
other
build
one,
up.
right? Yep.
This is like the Game of Thrones build up.
All right. 7 of 13. Subnet mask.
I wonder.
Did you get it?
You have to make those noises when you do this math.
Wait, nobody got that one?
I didn't get it right.
See, it's not that I know it's not that people don't know how to do it. It's straight
It's
up
the stress.
it's the stress of
having
needing to do it
so
quickly.
fast.
Yeah.
Yeah.
That one's for Chris. Not sure if an acronym I don't know or just a typo. Since it took him like 3 tries to get that thing. All right. Moving right along. The Cabaginator. In the
Wow. It's a close game.
lead. It is.
It is close.
These guys are killing it. So Tony, where did this one come from? Because this was your question.
Yeah, that one came from a network collective community member. That was from Nash.
Nice.
Yeah,
Very
and
nice.
when she sent me that, I was like, I have no idea what you're talking about.
Not a clue. I put this in and I'm just trusting the fact that it's actually true. Oh, Thomas coming out with that one.
Yeah.
All right. Another sequence.
Oh, and I like that. I just watched Aladdin the other day with my kids.
Probably one of the best
It's
Disney
one of my
films.
favorite Disney movies. Yeah, definitely.
I think it's biased because it came out when I was the prime age
Yeah,
for Disney.
Nobody?
Ooh, so close.
I got it right.
Yeah, just not enough to.
Right.
Yeah.
Oh,
I
okay,
just did it slow.
yeah.
My math is slow tonight.
So, in honor of WandaVision, what is the Scarlet Witch's real name? Is it? Are you guys watching WandaVision or no?
No.
Yes, I am.
So good. So good.
It is a good one.
It is.
Mark Hayes says we can't hear Thomas. Thomas, are you saying anything? Are you on
Really?
mute?
No?
I hear you now, loud and
Yeah,
clear.
I hear him now.
Oh, wow. I've been on mute for the last... Nice.
All right.
Why are the icons for video mute and audio mute different colors? Red is to mute the video, but green is to mute the audio, apparently.
Maybe
It's okay, Thomas. We can answer trivia. We can't figure out how to operate this thing. Let's figure it out.
Tony, I think we're gonna have to spend some time being guests. Although you do this every week, and do a video for our guests to let them know what's up. Because, all right,
Yeah.
pulling ahead. Second to last question. Another sometimes asked question.
Like,
I'm not even going to try. No. Just guess. Well, I guessed wrong, I'm sure. Now that I know to think about it.
Both of us did.
So we have two programmers on who you would think, binary math should be, back
but-
on
Alright,
type
so-
stuff. But yeah,
But why even try to memorize it? Because the computer does it for you.
I'm the biggest advocate for that. Not memorizing stuff you don't need to memorize. I'm with you.
But wait a second. There's a whole easily fingered operation to do that. You don't have to memorize it. It's like
Maybe this is a topic for the live stream.
and I just want to say something else before we do the last one. Before we do the last question, I just want to say something else because I know you both are programmers, and someone in the Network Collective Slack had said, so this is like a C versus Java game. So I actually tried looking for little snippets of C and little snippets of Java that I could say what is the math operation? What is the answer of this math operation? But I just couldn't find any that fit in the game. So Donald and Tom, should you guys find yourselves head to head again, I will get some coding questions in there, some real ones.
You should do things for programming languages we don't use.
So we
Fine.
need
You wanna
to
play a hard
translate
game?
this into C and into Java. There you go. All right, we ready for the last question? It's close enough. Either one of you
Yeah,
can
it
win
can
it.
go either way.
They can go either way, so it comes right down to the last one. Little Lord of the Rings fun here. Oh, both of them click fast.
Wow.
All right,
Fastest guns in the East and the West.
here we go.
I've only seen that movie a million times and read the books.
So Donald
So
takes
close.
it. Donald, but what a good game. You guys were very, very close.
Wow.
Very, very, very
Excellent.
well done. So,
Excellent going against you, Thomas.
yeah, Thomas, well done. So Tony, do you want to tell him what Donald wins?
Yeah. So for being a end of the month network trivia champion winner, we are going to give you a 1 year membership to the Network Collective, to the Network Collective Slack. But since you are already a member of Network Collective, you can either use that for your next year if you choose to do so, or you can also give it away to somebody of your choosing.
Yeah. So for those who are watching, if you're not a member, this is a great way. You can play trivia. You can win your way into membership, and you don't have to pay us anything. So so anyway, so yes, that's the prize for winning the month. So good job, Donald. Thomas, man, I thought you had it. You came in strong. I thought you were going to take it.
Yeah, it was close.
It was very, very close. All right, guys. Well, thanks so much for playing along. This has been a lot of fun. We'll keep doing trivia. If Donald keeps winning, though, we're gonna have to pull a Chris Cummings and eventually have like a hold down timer for him. All right, guys. Thanks again, and we'll see you both here soon. All right.
Thanks.
All right. All right. So there's the answer to the question. So the answer to the question is Donald is just as smart as a Donald. That's what it comes down to.
I keep trying to play the sound effects on the soundboard. They're not working for me. So I tried to key in for the claps and the trombone and the crickets. I got nothing.
Nothing.
But I there we are. But I love that graphic. It's just it's very fitting. I love it. I blame the knowns for Donald winning. That's awesome.
Okay. So next up, we're gonna bring on Chris, right? And
that's right. So Chris Greer, we invited him on. I met him at SharkFest, and he graciously said, "Yeah, I'd love to come on and talk protocols with you guys." And we were like, "So what should we do?" And he's like, I said, "Let's take it back to the fundamentals. Let's do a deep dive on TCP, something we haven't done as part of Network Collective yet." And
in 4
he was
years,
all for it.
We haven't really touched TCP, which I think is like most network engineers. Like we learn all the stuff around it, but it's just not something that's taught in depth, at least in most of our studying. So why don't we bring him on? So Chris, man, welcome to the show.
Great to be here, guys. Thanks for having me.
Yeah. Oh man, Chris's audio sounds all crisp and clear. Man, he's got a nice setup there.
Yeah, he does.
He's even got like the. I don't know what you guys were like when you got your school pictures, but mine were called Life Touch, and he got the whole like Life Touch background.
He does. It's got the vignette, fading to dark on the outside. It looks great.
Well, I was going to go for
sweet.
the universe background like Jordan's got there, but I couldn't get it up there in time. So you didn't
know.
It's like high school, right?
Here's a little factoid about our show. These are Jordan's pictures. He does astrophotography, and those are his pictures. Like he takes those.
Yeah, that one's mine.
That's sweet, isn't it?
No way. Nice job, Jordan.
Yeah,
thank you.
That's sweet.
So here, I'll pull it up so you can actually so you can actually see it. So this one's
wow.
This one's the Heart Nebula. So yeah, that's the hobby. So here's that's the hobby when there is ever non-cloudy nights. And so this week was a very bad week for astrophotography because I've waited 6 weeks. It's been 6 weeks that I've not had any clear nights at all. It's been like today is a good example of what my days have been. Crystal clear day, blue sky, not a cloud to be seen. And right as it gets dark, all the clouds roll in and there's just no taking pictures at night. And it's just been that way night after night after night. And so this past weekend, Saturday night into Sunday, it was a clear night for the first time, like I said, in 6 weeks. I was so excited. And I got all my gear out, which is an effort. Like it's not a small setup. You get all your gear out, you get it all set up, and I go to get it aligned, and everything over the course of 6 weeks has fallen apart. Like the whole thing just straight up didn't work. And I spent all night troubleshooting it. Now I live in Pennsylvania. Unlike Chris, who's coming from San Diego, there's a reason why he's wearing a short sleeve shirt, because it's beautiful there all the time. Here in Pennsylvania,
kind of nice guys.
Yeah, it was last Saturday night was negative 10 Celsius. It was a little cold. And so, when you're troubleshooting your gear and it's below freezing outside, it was an unpleasant experience. I was not happy. It was really not happy because I'm like, how long until I get another clear night? And I went from like 7 o'clock at night till 1 o'clock in the morning trying to get it running, and finally just gave up and pulled it all in and said, it's just not going to happen. So I'm waiting for my next clear night. Looks like I might have one this weekend. So we'll see if we can't get it going. So enough about my astrophotography though. That's not why we're here. So Chris, we are excited to have you on to talk about TCP, man. So why don't you give us a little bit of your background? Like, we kind of explained, we asked you to come on. I know you and I think Tony's taken one of your classes. Is that correct?
Mm-hmm.
All right.
Yeah.
So what is it that you do?
Yeah. So I am a packet consultant. Doing trace file analysis, primarily through Wireshark. So people have problems and they'll call me up and say, here's a trace, what do you see? Kind of thing. And when I'm not busy actually trying to fix the problem, the other part of what I do is teach. And you can find me on YouTube. Maybe there's some of the YouTubers out there that are on this live stream right now. And yeah, so if I'm not trying to fix it, then I'm trying to teach it.
Very, very cool. And we've got a couple links to some of your content. We'll drop them in the chat since we have that working now, Tony. To drop the links in the chat while we're kind of going here. First up though is just to kind of give everyone a heads up. You have a packet capture that's available if people kind of want to follow along. Is that correct?
Yes,
so
I do.
We're going to drop a link in there. So if you want to follow along with everything that we're doing here now, we're going to drop that link in the chat here right now. Go ahead and go grab that. And so while we're kind of doing this introduction and chatting, it gives you a chance to go grab that. So Chris, how long have you been doing this consultative role? Have you always done that? Have you been a network engineer, more traditional network engineer, and you kind of got into this, or did you kind of take a different path?
Yeah, good question. So for me, I started the network world back in the about 2000, 2001 timeframe, and I was doing the network engineer track. So I started out got my CCNA, I was headed toward my CCNP, and I worked for a company that specialized in making analysis tools. That's what they did. They build network troubleshooting and analysis tools. One of the tools they have is a protocol analyzer. And what I noticed is that in traveling around that protocol analyzer on different networks, that I would get into these scenarios where a problem would occur, and then the blame game started, and network guys were blaming server guys, and server guys were blaming wireless, but it just bounced around. And then I noticed that these packet people would come in and just grab a bunch of traffic, and then boom, 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 there's the issue right there. And I saw that, and I was like, wow, there's so much in the packets. So I got hooked, and I started to do technical support on that product. And then for about the last 10 years, I've had a company called Packet Pioneer. And so I'm doing, if not troubleshooting, then consulting. I also worked for a company called Network Protocol Specialists, a guy named Mike Panaki, who he was a mentor for me in getting going in the packet analysis world. So but I started out in the network world, learned my fundamentals, and a couple of those answers during the quiz, I was going /18/18, Is that?
Well, now, Chris, we know we got to get you in on trivia one of these times. We got to put you under the pressure as well.
Yeah, I know, under the gun. Yeah, I know. Like you guys are saying, it's hard when you're under pressure. But that's the pathway that got me into packets, and then I just got hooked.
Very, very nice.
Yeah. So I just wanted to kind of jump in and say that, like, one of the reasons that I invited Chris here was because, I completed my CCIE last January, and I met Chris sort of officially last October at SharkFest, at Wireshark Fest. I always wanted to go to SharkFest, but it was always sort of at the same time as Cisco Live, so I just couldn't make it happen. And so finally, because of COVID, it was online, and you guys did it in October at a completely different schedule. So I took Chris's class, and, being a CCIE, in a sort of network operations or network engineering role, you're considered, from some people, the expert. And sometimes they think you're the expert on everything. And there's been many times when people haven't been able to solve a networking problem from the devices themselves. So they resort to pulling a PCAP, right? And they say, hey, Tony, can you come over and take a look at this PCAP? And I'm like, yeah, sure. Prior to your class, I'm like, yeah, sure, I'll take a look. I have no idea what I'm looking at. You know what I mean? Like, it's TCP, is UDP? I don't know what good looks like. I don't know what bad looks like. I don't know what sideways looks like. And while we kind of we know what they are, right? There's a three-way handshake, there's sequence numbers, there's a reset, there's a FINAC, okay, we can kind of know it, but how do we know if there's latency? You know what I mean? How do we know if there's out of sequence? How do we know these other things, and how can we actually prove it? And when I took your class at SharkFest, I was absolutely blown away by just how much there was to learn about just TCP itself. Forget all the other protocols that are out there and all the other routing protocols and everything, just TCP. Because you know what? Everyone in the world doesn't use BGP every day. Everyone in the world doesn't use OSPF every day. Okay, but every person who's touched the internet is using TCP, whether they know it or not. And the fact is whether you're a CCIE or not, you probably don't actually know TCP the way you should. And so I kind of felt a little bit ashamed when someone came to me for help, and I'm the resident networking expert, and they came to me with a simple trace file. And I couldn't do much more than they could. I just didn't know what I was looking at. Since taking your class, it's like lit a fire under me, and really, I've been diving into packets now all the time, and now I kind of like always look back at that, and I want to make sure that when someone hands me a trace file, I know exactly where to start, and I can start breaking that down, and I know what to expect from the protocols. And that's why I invited you here to talk to the rest of our, network engineering community, because if I found so much value in it, then I'm sure so many other network engineers will as well. So thanks for coming on and sharing your time with us, Chris.
Fantastic, Tony. And that's a great setup. And I think that what you said is just really such a profound point in the OSI model. And really just as network engineers coming from growing up in the network side, I'm responsible for layer 1, 2, 3, hands down. That's me. And I might just put a little toe up into the network, the transport layer with firewalls and maybe some other rules that I'm working with. But when it comes to the actual TCP endpoints, hey, that's in the server. That's not me. So that's the perception, right? So that's a lot of times why it ends up being kind of this hot potato that gets thrown around a little bit. So.
All right. Well, Chris, what we're going to do is we're going to hand over control to you. We're going to bring up your desktop. You can talk through it. We're going to be here. We might chime in, but we're really giving you the reins to kind of go with it where you want to go. If you're watching or listening right now, please, shoot your questions in, and we'll get them into the show here, because if there's something specific you want to know, that's the reason why we do this live, as we want to make it interactive. So very, very cool. And without further ado, man, Chris, it's all yours.
All right, let's do this. So let's get some hands-on. That's the best way to learn, right? So we're sharing my screen now, right, guys? You can see me okay?
Yeah, it's there.
Yep.
Okay, fantastic. So I went ahead and opened up this trace. This is one that we have just shared with you. You can go out there on CloudShark, and if you want to download it into your copy of Wireshark, you just go up to Export, Download File, and then you can pull it locally, or you can just goof around with it in CloudShark too, which is the cloud version of Wireshark. So we talked about, when it comes to this live stream, we were talking about like 10 things about TCP that every network engineer should know, or just 10 points about it that will be really useful to network engineers in general. So I think, Tony, you just mentioned how a lot of times we know about the handshake and the flags and things like that. And those are important, but really even just taking the first 3 packets of the handshake, we're going to learn several of the things that every network engineer should know about TCP. Okay, so let's go ahead and take a look at the very first packet. First packet of the handshake, 3-way handshake, SYN, SYN, ACK. Great, we've all heard it. But let's now see how much we can extract out of just those 3 packets. This is why when you're capturing, get the handshake. You have to get the handshake. Don't capture something midstream. So if I have a user that has a problem and they already have the application running, you want to make sure that they back out, shut down the browser, shut down whatever it is they're doing, start your capture, then have them start from scratch doing whatever it is they're doing, because we need to make sure that we get those handshakes. Why? Well, let's find out. So first of all, I got my SYN. Okay, so just from our SYN, let's take a look at some of the things that we learn. Okay, we got our Ethernet header. We talked a little bit about the Ethernet addressing that we saw in one of the questions earlier. We got our IP info. We're going to go straight into TCP. So we got our port numbers. Hopefully we're familiar with those and what some of those values are that we're used to working with. Sequence number raw. So it's nice because Wireshark actually does us a solid here. Wireshark says, you know what, as human beings, you probably don't like looking at this big, long, scary 4-byte number. And in fact, if I select that number over here, sequence number raw, the true number that this client is sending to the server is this big, scary 4-byte number. And if I flip that over to decimal, there it is. Now, as a human, I don't like counting up starting at this number. I like counting up starting at 0, right? I like starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't like starting at 2,395,000,000, blah, 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 blah. Right? And then going up and counting 10 values forward. So Wireshark says, you know what? I'm going to make sure that you don't have to worry about that raw number there. That's the actual number. I'm going to do this relative sequence number thing, and I'm just going to zero this thing out for you. Cool? That's what Wireshark does. Pretty nice it does that. Now, the sequence number does become, Because, all right, network engineers, if this packet gets sent through a NAT, if it gets sent through other network devices, sometimes those devices, depending on their function, might terminate this connection and start a new one. Maybe with in the case of a WAN accelerator, or maybe even some load balancer. It just depends on how the load balancer is configured. It can either terminate it and start another one, or it could pass it through. But a lot of times when we're doing endpoint analysis, like if I capture something on the client, capture something on the server, and I want to make sure that I'm taking a look at exactly the same TCP thread, even through a NAT, a lot of times a sequence number will live. So don't just throw away in the back, all forever this sequence number. This is actually something that we can filter for. And if I have two trace files, one on client, one in server, I could set a filter for this sequence number, and I can find the same SYN in each packet based on that. Okay, so just one little tip. That's something that every network engineer should know. Now notice the next sequence number is 1. So when I send this SYN to the other side, I send something called a ghost byte. I call this the "did you hear me" byte. Now it's not actually a legit byte of data. I'm not actually sending a true byte. Instead, what I'm doing is I'm saying, hey, Tony, here's a SYN, and Tony is going to increment my sequence number by 1, and then that will be the number he sends back to acknowledge my SYN. So that's why it's called a SYN, because I'm actually synchronizing sequence numbers. I start at a randomized number that we have right here. Tony starts at a completely different number. His number has nothing to do with my number. He doesn't use exactly the same sequence number on his side to increment his data, to count up from 0. And I don't really care what his is either. He just has to tell me what it is. So that's why these are called SYNs. I'm sending a connection. Here's my starting sequence number. And let's take a look at what Tony said. Tony, you're just going to be my server, okay? I'm just going to call you Tony over here. I could rename this if I want, but I'm lazy. So
no, it's good.
51.
I'll take it.
All right. So 51 milliseconds later, by the way, I have a delta time. So if you've never set one of the, I actually have a YouTube video that I just put out an hour ago on how to set up Wireshark. You might notice I have these bright green SYNs, and I've got this screen layout, and I've got this delta time. On my YouTube channel, go check it out, because I literally just dropped a video that shows you how to do all of that setup. Okay, so you can go learn how to do that. But delta time is really important in a handshake, because I see my SYN go, and when I see a SYN-ACK come back, I learn several things, and so does Wireshark. First of all, Tony was there. He was listening. He had availability to support a new connection, and then he went ahead and sent his response. Now his ACK number, you see ACK number 1? All he did is he took the ACK number, or the sequence number, that I sent him, he increments it by 1, and he responds with a 1. This 1 tells me he got my SYN, that he got the correct one, and we're good. At the same time, Tony sends me his scary 4-byte number that Wireshark says, hey, don't worry about that 3298 blah, blah, blah number. Just start at 0. He also is doing a ghost byte function. So just looking at sequence and acknowledgement numbers, by the time that I get down to the third packet of handshake, this is why you always want to see this in Wireshark. Sequence number 1, acknowledgement number 1. I sent my sequence number to Tony. He heard it. He increased it by 1. He sent me his. I increased his by 1. That was the ACK number that I sent back. Now we're locked and loaded. TCP had to do this. So now we know where to start from. Now, when I send data to Tony, I can increment my sequence numbers based on the number of bytes I send him. Okay, so TCP is just a stream of data. Every byte represents one sequence number. Now, the same is true in the opposite direction. When Tony's sending me a stream of data, he's going to gradually increment his sequence number. I'm going to use that number, those values, to acknowledge the data he sent. That's how this connection works. This is why it's a connection-oriented protocol. You send data, incrementing that sequence number, and then that sequence number gets acknowledged. That's how I know whether to retransmit something or not. Okay, so let's just take a brief look of how that looks. Let's go to packet 4. This is another thing that network engineers really need to understand. So we did our handshake. I'm going to go back to the handshake in just a second. We're going to pull a few more things out of it. But while we're on the topic of sequence and acknowledgement numbers, we've went ahead and established our handshake. This packet 4, if I take a look at my length, this is 571 bytes. But if I come down into the actual TCP stuff, there's 517 bytes in the payload. Okay, so if I take away I got 14 bytes in the front for my Ethernet header. I've got 20 bytes for IP. I've got 20 bytes for the TCP, and then I have the Encompass data. All right, so here I am with my Encompass data. My sequence number that I'm starting out is 1. I'm sending Tony 517 bytes. My next expected sequence number that I will start with, the next packet I send in this direction, is going to start at 518. Okay, so sequence number plus length equals the next one that I'll start with. Well, guess what? This is also the number that I'm going to expect Tony to respond with as an acknowledgement. That'll let me know that he heard me. Let's see what happens. Let's go ahead and go to packet 5. There's Tony. He came back and he went ahead and said acknowledgement number 518. Sweet. Now I don't have to retransmit packet 4. If I didn't hear back from Tony within a certain amount of time, TCP is built to be reliable, right? So it will retransmit. It's going to wait a timeout, and then it will retransmit that packet. Now, as we go along in the packet stream, we're going to talk about selective acknowledgement and how he could do a triggered acknowledgement. But just at the beginning, we can see how these sequence numbers increment. They increment in both directions as data flows. That's a really important skill for every network engineer to master: sequence and acknowledgement numbers and how they increment. That's how we can find missing data. That's how we can figure out, hey, where along the network are things dropping? How much data is getting lost? Am I losing 1 packet, 10 packets? Did I lose them out of some buffer as we were traversing a router? So sequence and acknowledgement numbers, important. Let's go back up to the handshake again. And something else I want to make sure you guys are super solid on is this network round trip time. Now, what Wireshark will do for us is it will take the delta time between the SYN and SYN-ACK, 51.2 milliseconds, and it will add that to the delta time between the SYN-ACK and ACK. That total delta time, so from my SYN to the last packet of my handshake, is called my initial network round trip time. Okay? Initial network round trip time. If you take a look at really any packet, or let's just take a look at packet 3, if I select this and I come down to my sequence acknowledgement analysis, you are going to see this IRTT. Now, Wireshark does that for us. Anytime we have a value within the hard brackets, that's a Wireshark-derived value. That tells me this connection took 51.3 milliseconds to establish. Now, latency, right? Now I can start to get an idea of how long is it taking my connections to establish. This is a number. I can do a right click. I can say apply as column. And if I have a bunch of different connections, this is just one nice filtered connection that we have here in this trace. But imagine if I had thousands of them. I'd start to be able to take a look at, is this number drifting for different connections? Is it 51 in some cases? Does it go up to 100 in some cases? I can sort this column. I can say, what's my worst IRTT for any TCP connection in my trace file? If I wanted to, I could even come down and I could right click this guy. I could say prepare a filter, selected. All right. So now tcp.analysis.initial RTT. What if we did this? What if I said .2, so 0.2, and I want you to show me anytime that value is greater. So now I can create a filter that says, hey, show me any TCP connection that has an initial network round trip time larger than 200 milliseconds. And I can just sit there and let that thing cook. In fact, better yet, I could come over here to my plus button and I could save that Plus, I could say that guy is a button over here. I never have to remember that filter again. So IRTT is a super, super important number for all of us to know when we're working with TCP. How long did this thing take to establish? Another tip for you, just with the handshake. With a glance, we can tell that we captured either on the client or very, very near the client. The delta time is between the SYN and the SYN-ACK. That's where our 51 milliseconds is burned. Instead, if we saw a SYN and an immediate SYN-ACK go out, then we saw the 51 milliseconds, that means we're capturing on or near the server. Or let's just say that I had a SYN go and a SYN-ACK came back 26 milliseconds later, and then 5 milliseconds later I saw the final ACK. What that means is I was capturing somewhere in the middle. Let's just say I did a TCP dump off of a router, and I've got a server that's 5 hops away, and I got a client that's 5 hops away. I'm right in the middle. Well, I can still figure out my IRTT by adding those two numbers together. I'm still going to get 51.3. So with a glance, we can tell where was this trace file captured. Am I client side? Am I server side? Or somewhere in the middle? That's an important thing for an analyst to know. Get our head in the packets, get our head to figure out, okay, where were we? Another tip. I haven't even left the handshake here yet, fellas. So people are like, oh, I know TCP, I got the 3-way handshake, but we can get so much out of those 3 packets. Let's take a look at the server. The SYN-ACK coming back from the server, okay? Now, something else I like to do, take this guy, and I'm actually going to right-click and just going to uncheck that IRTT just to get that out of there for screen real estate purposes. And on that SYN-ACK, what I want to do is, since I know I'm capturing client side, something else that I'll head check when I'm kind of digging around is I like to go to the IP header, and I'm going to come down here to time to live. And where am I going with this? Well, time to live, 59. Well, what does this mean? Well, I have 59 more hops that this thing could live before the next router kills it. But this also gives me a way to guesstimate how far away in hops that server is. Now, this isn't absolute, but in most cases, systems tend to standardize on starting TTL values of 64, 128, 255. Those are the common ones that you'll see. So whatever or just in the middle that terminated the connection, I can tell that likely that box is 5 hops away from me. It's unlikely that it started at 128 because that's quite a few hops to go through. Same thing with 255. But it's pretty likely that this thing's about 5 hops away. It was routed 5 times. It started at 64, decremented down, and we captured it at 59. That also is a really good way to figure out where's my capture point. If I see TTLs of 63, likely whatever is sending or whatever is the 63, whatever that packet says is 63, likely they're 1 hop away. Now, the reason why I keep saying likely, and in most cases, you do find your one-off scenarios. You're going to find a strange driver that was written that uses a 27. Or honestly, with IoT devices coming on and all kinds of IP stacks and TCP stacks are borrowed from who knows where, you're starting to see some interesting values here. But generally speaking, it gives you an idea of how many routers have touched this SYN-ACK. Another thing we got to know, especially for network engineers, again, first 2 packets in any TCP connection, we have our options. So I'm going to expand TCP, and I'm going to come down here. We have flags, okay? This is something that was funny looking at the chat earlier here, you guys, with your SYN or your TCP flag humor. But this is what actually tells us the function of that packet. Is it a SYN packet? Is it an acknowledgement? Do we have push, reset? Go to my YouTube channel. I have short videos on all of those different flags, so you can learn a bit more. For purposes of time, I'll move on. Our options are really important to know. Okay, so only in the TCP SYNs do we see the options for that connection exchanged. Basically, this is laying down the ground rules of the relationship. Okay, so I support these options. I don't want you to send me anything larger than 1460 bytes of payload. So this right here, this client is saying, hey, Tony, don't send me anything bigger than 1460 encapsulated. That's it. That's my maximum segment size. Don't send anything larger. Tony could disagree. He could say, 1300. Chris, that's my MSS. The thing about MSS is we don't have to agree. Each side is just an advertisement of what they can receive. Now, as we know, network engineers, especially this kind of crowd and the CCIEs among us and otherwise, that's a number that the network could change. So I could let it go at 1460, and a router could say, ooh, I got some stuff that I got to append to this guy. So you know what? I'm going to take that MSS and I'm going to drop it down to 1432 and I'm going to go ahead and let it go. So that way we have some header room. 1460 is a little too much payload. Once you add TCP and IP and Ethernet, we're getting toward our MTU. So we need a little bit more payload space for these other things that we need to do. So MSS, it's only exchanged once and it's right there in the SINs. Window scale. So window scale, what this does is it allows us to get more out of our receive window value. Okay, it allows us to get more out of our receive window value. Do this. Select window. If you look over at the hexadecimal view, you see our hex view over here? 2 bytes. What's that mean? The window, that's how much data you can send me outstanding at once without an acknowledgement. Think of it as a receive buffer, for lack of a better way to put it. So I'm saying, hey, Tony, don't send me any more than 64K, 64240. And Tony's like, I'm on the other end of 100 gig, what if I says a 10 gig connection with 100 milliseconds of latency, and you can only take 64K at once? It's going to be a long day for TCP. So this value back in 1981, when TCP was ratified into a standard, RFC 793, TCP turns 40 this year. But back then, they never thought that you'd ever need a receive buffer larger than 64K. Come on, think about the networks and speeds and feeds that they were pushing back then. So what the options did, TCP options said, you know what? We don't have room in the header values without breaking other things to make this larger. So what we're going to do is we're just going to add a multiplier. So what I say is, hey, Tony, I'm going to send you 64240, but when you see that value, multiply it by 256. So that's my real TCP window. So we can see that this whole TCP window can get a whole lot bigger. In fact, I can have now, if I use the largest window scale with the largest window size, I can tell Tony, I've got over 1 gig receive window now. Tony, you can just fire hose whatever data you got, send it over. That allows us to take advantage of long fat networks where stacks, TCP stacks that don't use a window scale, we're only limited to 64. So guess what I do? As a network analyst, when I'm looking at handshakes, I'm just telling you guys some of my checklist things that I go through when I'm looking at TCP. Do we have a window scale? What's our MSS? What's our starting window size? Are we using selective acknowledgement or not? And if I find out that, hey, this client is using selective acknowledgement, hey, Tony, are you using selective acknowledgement? Well, we got to go to the SYNAC and we got to find out, does Tony also use SAC? Because if he doesn't, I don't get to use selective acknowledgement. That's a very important way of us being able to recover from packet loss without needing to retransmit a bunch of data unnecessarily. That's another TCP option. Check out my YouTube channel. Got a bunch of stuff there. But check out Tony's window scale. He's like flexing his arms here. He's like, oh, you want to do 256? I got 1024. Check that out. So what this means is later on in the connection, I'm just going to randomly pick a packet, guys. Let's go down to packet 10. All right, so this is the client to server. If I come down to window, the window is 514, but when you add the scale factor that was told in the handshake, Tony actually can send me 131K at once without acknowledgement. Now, what's all this mean? Well, basically, you can start to see how TCP uses these values to be able to efficiently and reliably transmit data to the other side, and if loss happens, to recover. But there's a super important thing we have to know about TCP. TCP knows nothing about the network. All right? I don't know. Let's just use a water example, right? I don't know the size of the pipe. So Tony's on the other side. He's my connection partner. I don't know if we have a drinking straw between us or if we have a huge sewer pipe that can handle a bunch of water between us. Are we on the other side of a T1? Is he on the other side of an ocean? Or is he next door in the data center and I've got a 40 gig link between us? TCP doesn't know. So all these values are things that TCP uses: network round trip time, retransmission timer, even congestion window. Unfortunately, I probably won't have time to get into that with this conversation. But these are all things that TCP does to figure out what's our network and how aggressive can I be with sending data without pushing out Jordan and elbowing everybody else out of the way. I'm going to pause for a minute. How we doing, guys? How are we feeling about TCP?
This is great so far.
That's great.
The IRTT is something I'd never considered. So I've been doing networking for a very long time, but specifically how you use it to figure out where you are capturing. Like the amount of times that I've had to go back to the source, like if I didn't pull the capture myself, like I had to go back to the source and be like, where? Because I mean, it's a critical thing to know because you need the context about what you're looking at. And so like just looking at a random capture doesn't tell me anything. Was this the client machine? Was this the server machine? Was this some middle box that we pulled this from? And almost never do I ever get the capture with the context of where it was from. And it's cool to use that to kind of just deductively look at and say, hey, like who originated this conversation? And then like, what does my round trip look like? And deductively, it's completely logical. Just never even considered it. It's awesome.
Awesome. Yeah, good.
Tony knows this all because he's already been to your class. He's like, this is
I was going to say that. Yeah, this is old hat now. But definitely, you've been getting a lot of kudos in the chat that you've been dropping a lot of tips and a lot of people are picking up that they didn't already know. And this is a group of, full, professional network engineers, who make their living, routing and switching, all day and every day. And you're showing them things about protocols that they're using right now that they didn't know. And that's why I asked you here, man. I personally, guys, this is so fascinating to me. Like, now that my CCIE is done, I don't study protocols anymore, or routing protocols, I should say. Like, I'm deep diving packets, and it's because of info like this. I mean, one of the things we brought up in chat was the IPTTL. Knowing maybe it was that local firewall one hop away that's sending you that reset. It's not actually the server. I use that all the time now, when I get called into a troubleshooting thing, they're like, oh, the server's sending me a reset. I'm like, well, how do you know? Like, well, I got a PCAP. I'm like, let me see the PCAP. It's got a hop count of 64, so I don't think so.
Yeah, now every time I see totally a reset, TTL, right? One of the first things I do is look at TTL. Who sent this? And if that TTL is different than the surrounding packets, then the endpoint didn't send it. What firewall is trying to stomp this thing, right?
Exactly. So, yeah.
So my point here, guys, was to show the audience, and hey, it's great to have some of the chat. I see the chat coming in. This is awesome to see you guys out there. But really, I just talked to you for a half an hour on 3 packets. Like, that's what we can squeeze out of the handshake. You know what I mean? So never again, if there's just one thing to take away from this, TCP is not just a 3-way handshake. Look how much we can glean out of those 3 packets and the timers. We're not even talking about some of the bytes in flight and some of the other measurements that Wireshark can do. But I'm with Tony on this. The deeper you get into this type of analysis and you see the power of the truth of the traffic that's on the wire, it's fascinating to get in there. And that's why I love teaching it. It's fun. In fact, next Monday, if you guys don't mind me plugging for just a second, I got the class that you took, Tony, the 2-day, basically network analysis and TCP with Wireshark. So now that's a class that I regularly teach for Packet Pioneer. And so if you go to wireshark.org, and I think the guys sent out a link to the next one coming. Next Monday and Tuesday, I'm teaching one, and it's over Zoom, remote, same as Tony took it. But we basically, how many labs did we go through, Tony? Like 20 something labs. It's all hands on.
Each one is different trace file. Yeah, I still call them PCAPs. Different PCAPs, and it's great. I mean, you're diving into packets, answering questions. Can you find this stuff on your own and why? It's definitely cool.
Yeah. So anyway, that just to let the audience know, that's something that I enjoy teaching, and I invite anybody that wants to dig deeper or stay close to Network Collective. Maybe we'll get to take the congestion window next time or something.
I was going to say,
that'd be awesome.
We'll do this as often as you want to, because this was fantastic, and I know we're just scratching the surface. As much as you're willing to share, we're willing to do, because this is great.
And Chris, I don't know what you have planned for us to dive into, but one of the things that I also found so fascinating, so I just want to plant that seed, was some of the graphs that become available. I never used the graphs in Wireshark because I didn't know what they were showing me. I didn't know how to use them, and I didn't know how to interpret them, But once you start to understand TCP, then you start to understand the graphs, and it just makes sort of seeing, like the sequence graph or the Stevens graph, even though that's just like a pretty rudimentary graph as it goes, but it just makes it seeing it, I don't have to look at sequence numbers anymore, going back and forth and back and forth. I just need to see this. I'm good to go. Okay. This one's good. Not
so
a problem.
Talking about that, like, is that difficult to show? Like, let's bring it up if we can. Yeah, let's talk about that for a second.
Rock and roll.
Okay.
Guys, I just switched traces on you because the stream graphs are way better to show when we have longer data sets moving, right? So the sample I sent out to the fine people it's a shorter trace file. In fact, I'm kind of baiting you there, because you have one TCP conversation and you have a quick conversation too. Quick is a whole nother conversation that we're going to have one day on Network Collective. But this one, can you guys see my screen okay?
We're bringing it up now. Yep.
Oh, sweet. Thank you. Yep. All right, guys, you don't have this trace file, but you can follow along on my screen. First of all, what are our eyes doing right now? We see a SYN-SYN-ACK. Okay, so immediately, any network engineer, boom, network round trip time. All right, so I'm looking at 105 milliseconds. That's my grassroots network round trip. There we go. Almost like a glorified ping, if you will, right? But this was the actual user doing something. And just to give you a bit of background around this trace file, this was actually just an iPerf test from one machine to another, and I had a WAN emulator that threw in 100 milliseconds of latency between the two. But the reason why I wanted to show you this one is because I'm moving, as I scroll through, without getting too deep in the weeds, as I'm moving data, you can see the big boys going 192, 168, 1.1 to 10. In the opposite direction, there are the ACKs. But something I'll do, again, what do my eyes do? What do my eyes grab for when I'm looking at a trace file like this? Well, first of all, I want to see, how often do I suffer 105 milliseconds or thereabouts? I suffer it there. I suffer it there. I suffer it there. As I'm going down, how many times do I eat that network round trip? Right? 100 milliseconds is bad if we suffer it a lot of times. Only 10 times is 1 second. 100 times, it starts to multiply, right? Humans are going to start to complain unless you only experience once, right? So that's something that I look at. But with those stream graphs, like Tony had mentioned, let me grab one of these packets. Now, it's important that I select a packet of data that is going in the direction that I want to take a look at. All right, so I'm not going to pick the ACK. I don't care about data going from 10 to 192. I care about data going from 192 to 10. I select this guy. I come up to statistics. Come on down to TCP stream graphs. Now here I've got 5 to pick from. I'm going to show you just a couple here. First of all, let's just start with throughput. All right. So, and oops, 10, switch direction. There we go. Sure enough. So whenever you go into these stream graphs and you see something flat that looks weird, just come down here to switch direction. You might have gotten the wrong direction, and then boom, it goes, oh, Chris, you meant this one. All right. So here we are. We're here taking a look at our data that's going in flight. And this represents the amount of throughput and segment length. We can see the segment length of these dots up here. All right. But here, throughput, I can see my throughput goes up and then it collapses and then it goes up again. And over here, I can actually measure it, right? So I can do my calculations of 10 to the 6th, 10 to the 7th times 125. So this should be 125 megs per second, right? That's what my throughput touches. It touches that ceiling and then it collapses and comes back up again. Now, what kind of things could cause that? Why would my throughput just suddenly collapse? Well, let's take a look at a different stream graph. Let's go to TCP trace. Well, right here, this is where I can see TCP trace. What this shows me, and I'm going to zoom in here. In fact, I'm going to zoom in this area right about there where that red, bad, ugly thing looks. Well, here I have data going. These black lines represent data going up. These are sequence numbers over here. So my data in this direction, sequence numbers go up, then I wait, then sequence numbers go up, then I wait, sequence numbers go up, then I wait. Well, if I dig deeper, you know what every single one of those waits is? It's my network round trip. So right away I can see TCP is sending data, then needing to wait for acknowledgements to come in. This brown line is the level to which I have acknowledged in the opposite direction. The green line is the amount of space I have of bytes in flight to the receive window on the receiver. In this trace file, you can see that my dark line is hugging the green line. It's hard to see on your screens. Let me see if I can get a little closer here. Here's a green line. As the green line goes up, so does the black. It's almost like the receiver says, hey, I've got a few more. I'm processing some data out of my buffer. Go ahead and send a little more. And the server's like, sweet, boom. It sends as much as the receiver can possibly handle in that receive buffer. Okay, let me reset for a moment, but these red lines can't be good. So let's go and zoom in there. So these red lines mean that a lost packet happened. There was packet loss somewhere. And in fact, I can go back into the trace file. If I come into drags here, and if I actually click around here, that's what's kind of cool. If you click somewhere in the graph, you see the packets in the background will jump to that point. So I'm going to go ahead and take a look here. Let me close this out. So the graph led me to the pain point, right? So I clearly saw things aren't going up in a nice, smooth way. Not only do I have that stepping, but I also have that period of time where it's just flat and then red, ugly. Let's go back into my capture. Well, sure enough, the dupacks can't be good. Let's take a look what's going on. Let me scroll up. See, here I've got data in flight. Data was in flight. But then the receiver comes back and says, whoa, dupack, dupack, dupack. And then the sender says fast retransmission. So we were actually capturing sender side. We were capturing on 192.168 on this end. So it gets informed of packet loss. Super quick, guys. I don't think I have enough time to dig too far into this, into SAC, but in that dupack, what happens is I take a look at the acknowledgement number. So here's my ACK number, right? This is information that's coming. I'm sending data over to Tony, and Tony is acknowledging that data. Well, in that ACK number, so 434.7022, so he's saying I'm good to 43.47022. I'm good until that point. But then there was a gap in the sequence numbers. I'm missing stuff. But after that gap, I successfully received a packet. It's almost like Tony's telling me, hey, Chris, I got packet 1, 2, 3, 4, 5, 6, 8, 9, 10. All right. So he's implying, hey, 7 went missing. How does he imply that? Well, he tells me I'm good to here. But then if I come down to options, you see the SAC. So not to go too crazy into the weeds, the selective acknowledgement is telling me he's good, right edge, left edge. This is successfully received data. So let's just chop off the first numbers, but 49,942. So we're good from 49,942 to 51,402. And if we do the math on that, that's probably one full segment. But I'm missing from the acknowledgement number, I'm missing from 47,022 to my left edge, 49,942. I'm missing that part right there. So that's what that ACK number is telling me. I'm good to 6, I missed 7, and I got 8. The next DUPAC. Okay, the ACK didn't change, so I'm good to 6, I missed 7, but hey, my right edge grew, so I'm good to 6, I missed 7, but I got 8 and 9. The third DUPAC. Okay, I'm good to 6, I missed 7, but I got 8, 9, and 10. So I finally get the hint after it's called a triple double. This is a triggered retransmission. Tony sends these 3 to me, and I don't have to wait some long exhaustive timeout. Now I can go, oh, he missed packet 7, or those sequence numbers, the actual segment. I can just retransmit that guy, and I can do it immediately. That's why it's called a fast retransmission. Wireshark goes, oh, I saw these DUPACs. This happened faster than the network round trip time, or right around the network round trip time, or less if I'm capturing server side. This must be a fast retransmission. It was triggered. It was based on what Tony told me the behavior was of the sequence numbers. Well, after I let that guy fly, all of these DUPACs come in. That's because I already had a bunch of data in flight. Okay, so Tony, he's like, and I got 11, and I got 12, and I got 13, 14, 15, 16, 17, 18, 19. He got all the way to packet number 100. But all of these are indicating that packet 7 was missing. Now, I've already retransmitted packet 7, so I already know that it's in flight. Eventually, though, Tony catches up, and he goes, oh, cool. All right. This one right here, this packet, once we see the DUPACs disappear, that's where he advances. Instead of saying packet 6, I'm good to hear, I'm good to hear, he now advances all the way up to the stream that we have a contiguous bytes of data. He now advances, and now he says, all right, I'm good all the way up to everything you've sent, Chris. We're cool. That makes our congestion window collapse in TCP. TCP goes, we lost a packet. We got to slow down a little bit here. We hit our head on throughput. Maybe there was a T1 somewhere in the path, or some buffer lost a packet. Not all congestion algorithms are the same, but TCP goes, you know what, why don't we pull the brakes? So now it gets a little scared. You see this large packet? 1, 2, 3, 4. I only let 4 go, and then I wait to see how Tony responds. Tony comes back 100 milliseconds later. Tony says, cool, I got those. And I go, all right, I still don't want to put the pedal to the metal here. Let's just leak out some more data. So 1, 2, 3, 4, 5, 6 MSSs, 6 full-size packets. All those go in flight to Tony. Tony comes back 121 milliseconds later. So now every round trip, I add 2 MSS, meaning I open up the amount that I will send in flight a little bit more. This is why TCP is so important for network engineers to understand. Network lost 1 packet, big deal. Why did TCP collapse, though? To where we're just like down to the floor, completely out of gas, and then TCP has to rebuild back up to have good throughput, right? Is this a network problem? Yeah, we lost 1 packet, but TCP, why? I mean, really? For me, I would look at this as look at the congestion window and go, why are we completely collapsing our congestion window? Is there maybe a different algorithm that we could use that's a little bit less on the back off? There's a whole nother thing in this trace that's super fun to go into, but I don't know enough time, guys. But Tony, that was our stream graph.
Chris, we will definitely have you back on, and we'll maybe do this 1 or 2 more times, because I think that there's a lot here. I don't want to take all your content for your class, though, right? Because we want to make sure that you're still able to do that. But this was super, super interesting. on that continuing to build up to MSS every cycle, right? That will just continue until you get to the window size or until you get to the max window size. As long as everything's healthy, right? That's what we're doing is we're rebuilding back up to what our max segment is, that we're good without an acknowledgement.
Window size. So the limiter will either be the window size on the receiver, like you said, yes, or the congestion window also can reach a point called the slow start threshold internally, where I'll actually most of them will multiply by 2. So I'll go like 2, 4, 8, 16, 32 until that
scales up.
Threshold. And then it'll bend and it'll just go up by 1.
Okay.
And then sometimes it'll back down. Like TCP wants to float right where throughput is good. Like
right,
I don't want to hit my head.
It wants to find the edge. Yeah.
Yeah.
I'm 6'2". This happens to me when I go through doorways. I don't want to hit my head, but when I go through the network, I just want to tilt my head like this sometimes. I don't want to go down to my knees.
Right.
Just to crawl through a doorway.
Yeah.
So
very cool.
that's what TCP tries to do.
Well, very, very good. Chris, that was phenomenal. So thanks for coming on and sharing your insight there, because that was great. Now I know Tony just posted the links in the class, but I'm considering it too. Because I'm like, wow, there's a lot that I don't know, and not that I didn't know that I didn't know that, but it's like we just spent just 40 minutes. It wasn't like some big long session, and I learned a couple of things. That was great.
Yeah.
Cool,
well, thank you
Chris,
guys.
I just wanted to say I posted both of your links in the chat, so I know some people are grabbing them, and I'm sure we'll put them in the description to this video once we release it. Is there anything you want to say about the classes other than Chris Greer rocks, TCP rocks? Is there anything else that you want to say to plug the 2 links?
Sure, you guys are going to have a lot of fun. I mean, it's hands-on. We shred TCP. I mean, these are just samples, right, that I'm sharing with you. But I took a 3-day class, and it goes from basic network analysis concepts up to advanced TCP stuff. And I genuinely try to focus with the Wireshark analyzer on the things that I actually use as a consultant. There's a lot of buttons in Wireshark. There's a lot of toolbars and menus and things. But if I don't practically use it, right, I want this to be useful to you guys, a practical class, and also hands-on, right? I didn't learn this just by, reading a book. I got my hands dirty, and I had mentors that helped me through that. So I invite you to check it out. I've been able to strip it down to the most useful that I think information for 2 days. I mean, that's what Tony went through. Nope. And reach out to me. I mean, I can get you guys a coupon code so you can get a few bucks off the class, but go check it out. And it would be awesome to see you guys. Very, very cool. And your Twitter handle's right there, right? Packet Pioneer. So if you want to chat more, go find them on Twitter. So that's great. So thanks again, Chris. And we'll be talking again soon, because I know we've got a number of things that are kind of in flight. Now I'm using your terminology here for what we're talking about. Flight. Here we go. We've got several things, and I'm getting even more excited about it now that we've had some time to talk through the first one. So and you're getting tons of kudos on the chat too. So that's well done. Thanks, everybody. Right. Follow me on YouTube. Go to YouTube. Check it out. Go to YouTube. Follow absolutely. Twitter, YouTube. That'd be awesome to be in touch with you guys. And thanks both Jordan and Tony. This has been great. All right, Chris. We'll talk to you soon. Yeah, absolutely, Chris. We're going to finish this episode, and we'll link back up via email, and this will be great. Yep. All right. Good deal. Sounds good. See ya, man. Take care. So yeah. All right. That was. Can you hear me? Yeah. Yeah, I got you, man. Yep. That was stellar. Chris Greer, man. I'm telling you what, dude. I mean, I took the class at SharkFest. Like any conference, there's like some pre-conference classes you can take, and I'd seen Chris Greer on YouTube, and he does a bunch of short videos. I'm talking like 4 or 5 minutes of TCP at a time, which for me was about as much as I could take, because I was like, holy crap, there's a lot. So definitely, when the opportunity came to do, it was a 2-day class. It was like 8 hours each day. And let me tell you something else. I don't know if he does. He probably doesn't do it in his other classes. I don't know if he does, but at SharkFest, it was all through Zoom, with a bunch of other, packet hackers. And he played some like killer 80s music
for 2 days straight. He had like the most rockin' 80s playlist I've ever heard. And I am admittedly, go ask my wife, I am an 80s hater. And I'm an 80s hater because I hate synth drums. I hate the doom, tss, doom, tss. You know, like every 80s movie has the synth drums in it. And I just hate that sound. And so I'm against a lot of 80s music. Now, I mean, I was born in the 80s, you know, so my mom was a rocker, so I grew up in that. But I tell you what, Chris puts on a playlist that I did not hate. It was definitely cool, hacking through packets, rocking out to 80s tunes. So it was definitely a good time.
That's cool. So, So Tony, I think this is, cool. We're about time for your favorite part of the show.
Oh, I would do like sound effects, but it doesn't work for me.
What kind of sound effects do you want, Tony?
Drum roll. All right, and we're getting ready. Oh, I thought that was a longer drum roll than that. Okay, and we're getting ready for the nicest part of the evening. This is going to be Naked Hardware. Oh,
You need to get your desktop connected, man.
I am. I'm terrible at it. All right. I should be connected. Let me get my files over there.
Yeah, looks that way.
All right. So this was last week's I double clicked it popped up on the other window, other monitor. This was last week's challenge. So everyone, this is Naked Hardware. This is my favorite part of the show. This is how we close out our stream typically. I present you guys a piece of hardware without its chassis, out of its case, so you get to see just the circuitry. We take an up-close picture of it, and we call this Naked Hardware. You have to try and guess what this appliance is without any markings. So you just got to look at the circuitry, do your detective work, and figure out what it is. So go ahead and bring me up, Jordan. This is last week's, and we got a couple of people who gave us some feedback via Twitter. So I'll pull those up now. So this was last week's. This was a submission from a Network Collective community member. So thank you guys very much for submitting some images. One person specifically, I like to call him out, Preston. Preston gave me a truckload. I don't know if it's a metric truck or imperial, but a truckload of pictures, and so it's very awesome. So if anyone else would like to contribute to the Network Collective Naked Hardware Trivia, please go dig that hardware out of your closet, open up the cases, take me the picture, and send me what they are. You can send it to tony@networkcollective.com or find me on the Network Collective Slack. All right, that was a mouthful. So let's go ahead and go over what this was and then talk about our winners. This one was, I'm double clicking the image now. It's coming up. Preston says, there's more coming, Tony. Just have to find time. Absolutely, man. I really appreciate what you've given me so far. Thanks a lot, Preston. Mm-hmm. What we hear was a Cisco ASA 5506. So I have one of these in production somewhere that I can't get a picture of because it's in handling a boundary. Yep. Yep. Very good. So actually what I don't know is this the X model? Did what I don't know is, did Cisco release the 5506 and the 5506X, or is the X already appended to this one?
I think it's already appended, but I'm that's now becoming old memory, so I'm not quite sure.
Yeah. Even I think this guy is approaching end of life.
So Preston says it's a 5506X.
Oh, right on. Yep. Very cool. All right. So with that, we have two winners. I'm going to pull the images up now.
And the first is Preston. No, that's not the way this works.
So let me zoom in here. The first is Liam Keegan. Liam Keegan is someone I'm not familiar with.
I love that tweet. But I'm not questioning my life choices.
Yeah, I'm now questioning my life choices as I immediately recognize it as a 5506. And that's very cool. And I checked his Twitter profile, someone I didn't know and don't know. He's like an OG CCIE. He's got a 4-digit number. He's in the 5,000 range. So nice. Very cool. Yeah, old timey Cisco. So very awesome. So Liam Keegan, I'm going to reach out to you via the Network Collective Twitter and see if we can sync up, and we'll send you one of our prizes.
Swag,
and our prizes. Wait, our prizes. Let's talk about the prizes, Jordan. The prizes for first place. So Liam got first place on this one. It's one of our commemorative network hardware, Network Collective
naked hardware.
Mugs.
Coffee mug.
Naked hardware.
So there was some love for the logo in the chat as we played it, and so if you like the logo, you have to win naked hardware, because you will get one absolutely killer coffee cup that has that naked hardware logo on it, and it will definitely be a conversation starter if nothing else. Whenever we do get back to the office eventually, right?
That's right.
And it might be an interesting conversation with your wife too about what are you watching.
Yeah, what is that Network Collective stream rated? Does it say for kids? All right.
Chris is all in on the naked hardware mug. Well, Chris, man, you got to win. It's been a while.
Chris, yeah.
You got to win.
Okay, let's go ahead and take a look at our second winner, if we can. Second winner, I'll zoom in here. My guess is a Cisco 5506 ASA based off of this photo I found, as well as having a previous gen in my collection of retired gear shoved in a box. Network Collective sets. Fun Times Ninja.
That's a great Twitter name. Fun Times Ninja.
Very good. Yeah, very good. So I know who this is. This is actually a coworker of mine. So this is, I don't know if you remember last stream, there was a guy who joined our stream named Scott, and he was chatting a lot. This is a guy, Scott, I work with. So very cool. So thank you, Scott, for submitting. You are our second place winner. I will send you out a swag bag very soon. So, and thanks for playing.
So Preston says he wants a coffee cup, but he can't because he can't participate. I think we should send him a coffee cup for sending us pictures.
I think that's fair. Or what we do is we say, come on, community, come on, networking community, send me some more pictures so that we can post them and Preston can play. Because he obviously can't play on his own images. So
just to show it off to me, I want to bring it up because I still have the pictures from last week when you called me out when I wasn't ready. I'm ready now, right? So look at this.
Oh, look at that guy.
Naked hardware, right?
Absolutely.
And the opposite has the Network Collective logo. So yeah, it's pretty solid. I mean, you definitely want one of these for sure. Yeah,
super cool. Yeah.
All right.
So going back to it, I want to say while Mr. Kevin Myers didn't win,
Magic Jack.
I did want to point out that he was wrong. But he says Magic Jack, of course, says so right on the metal port of the far right. So I included this for a reason because I wanted to bring it up to the networking our community here. We've done a lot of these naked hardware, and I've looked at them closely. This is just something I do for fun. Magic Jack must have a patent or a production line of something because most Ethernet ports are labeled Magic Jack. And I was just wondering if anyone can provide me any sort of links or history or drop some knowledge on me on why most of the metal sheathing, the shielding that goes around the actual, the inside of the RJ45 is labeled Magic Jack. Now, I mean, I'm a kid from the 80s, so, I grew up with telephones, and I remember when they were advertising the Magic Jack for phone lines, right? You plug your phone into it, or you plug you plug something into something else. I remember seeing the commercials for it. I didn't really know what it was.
So Preston says it reads Mag Jack, and he says he's not sure if it's the same. So that's...
Oh, is that right? Okay.
That might be it. But yeah, Magic Jack, I had a when I was running like all of IT infrastructure for a national company, it was, I think it was like 80 or so sites. I had one of the people in IT who ran some of the legacy systems who decided that he's going to take it upon himself. He had nothing to do with telecom, come in and recommend that we just get rid of all of our expensive PBXs and just run Magic Jack everywhere. Just deploy them everywhere. I'll never forget that conversation. He ran DEC systems and they were archaic. And this was, over 10 years ago. So, that was an interesting conversation because he came in all hot and heavy. He's like, we're going to save the company money. It's going to be great. We're going to run this. Yeah.
So as we go through more and more pictures, I'll see if we can find more with the Magic Jack. In fact, I'll go back in the history of Naked Hardware and see if I can find some clearer images of them and see if they say Magic Jack or not. Maybe they do say Mag Jacks, and I've been reading them wrong. Without further ado,
we already have a link in the Slack. You already have your history. It's already there. Laz is on it. He just sent a link. Look at that. Ask and you shall receive. The
Network Collective Slack community is the greatest group of people. They're the greatest resources. I mean, if there's a network outage anywhere in the world, Kevin Myers has something to do with it, and someone else knows about it.
Yeah.
I mean, and you want to know some obscure history on something? I see Chris Cummings says, I've got a data sheet on it. So, I mean, yeah. There's an amazing group of people that have tons of resources. It's very awesome. All right. So without further ado, I'd like to introduce this week's Naked Hardware Challenge. I'll bring it up just for a second, and then I would tweet it out from the Network Collective Twitter account. And if you can respond back to that tweet with the hashtag Network Collective and with what your guess is. I'm going to bring it up here just for a second as a little teaser. There it is.
Now, see, that looks familiar to me.
Yeah, that does look familiar. All right, rock and roll. The rest of you can check it out on Twitter. I'll get it posted right after this live stream.
All right. Well, I think that about brings us to the end here, Tony. That was fun. So Chris was your recommendation. Awesome. That was fantastic.
Yeah.
So we'll definitely, we have a lot more lined up with him. So I'm excited about that. For all of you who are watching, thanks so much for joining us. I mean, I know it's 8 p.m. on a Wednesday. There's no real ideal time to run a live stream like this, but man, it's so much fun, the chat, the interaction and whatever. So just want to give a shout out to all those who are coming on and doing this live with us, especially those of you who do it week after week. It's just an absolute blast. If you aren't part of the Network Collective community and you're just kind of like caught this, like you found it, either you follow us on YouTube or you just saw it on Twitter or something like that. There's a couple of places to find our stuff. NetworkCollective.com. All of our past stuff is there. We do a podcast in addition to the live stream. So you definitely want to go check that out because there's 4 years worth of podcast content there. Lots and lots of great content that's worth checking out. If you're into podcasts, you can also find us on all the regular podcast places. You can head to, if you'd like to connect with us on social media, we're at Net Collective PC on Twitter. We're Network Collective Podcast on Facebook and LinkedIn. And so that's there. And if you are watching and you like what we do and you haven't done it yet, in fact, somebody joined today.
Awesome.
Yeah. We had, let's see, Richard Beckwith. Joined. He was like, I've been thinking about doing it. He left a message in general on the Slack. He's like, I've been thinking about doing it, and this thing with Chris was awesome, and it just reminded me I needed to go join. So we actually had somebody join the community during the live stream today. But if you haven't, you should consider it. Right? We just ask you to consider it because it helps us keep the advertising to a minimum. It allows us to produce the show and keep putting out this great content. It's not that expensive. We don't ask a lot. You can find all the information at networkcollective.com. Some cool perks there too that are definitely worth it. But the key one being the Network Collective Slack. That's a really, really great community. So without belaboring those points too much, I think that's it, Tony. Another great stream. And I think it's time to sign off, man. So again, thanks to everyone who's watching.
Let's see that. And don't forget, I'm going to do like the YouTuber thing. Smash that subscribe button and smash that notification button. They're down there somewhere.
Tom is laughing. Tom is laughing. He says 8 p.m. Thomas, who was on trivia with us, he's saying 8 p.m. and he laughs. Because like, I don't know, it's like 3 or 4 o'clock in the morning there.
Yeah.
Because he's in Europe. Yep. So, all right. So I'm sorry, I interrupted your smash the subscribe button.
Yeah. Hey, hit us with that Naked Hardware one more time before we close out.
All right. Here we go. All right. Thanks, everyone. We'll see you next time.